All right, so looking at compounds, I want to walk through the different ways that we can represent them. And I'm gonna do a few examples here, but I want to start with carbon dioxide. So that was a molecular, or sorry, a covalent molecule. It's a molecule. So the ways that we can represent carbon dioxide, the chemical, I can write its name all the way out, carbon dioxide. Or I can abbreviate it using its chemical symbols. And that's what we've done here, the CO2. So with the chemical symbols, this C equals carbon. So the C is the abbreviation that is the chemical symbol, and O is an abbreviation for oxygen. So I've listed the two elements that are present in the molecule. And then you'll notice there's also this subscript 2 as well, right here. So this subscript is telling me how many oxygens I have relative to my carbons. If there is no subscript, it means that there is just one. So we kind of abbreviate the structure even more by omitting anything that's just a 1. That means that I have a ratio here. I have 1 carbon atom and 2 oxygen atoms in every CO2 molecule. Now that's typically the chemical formula is like the fastest and most common way that we're going to represent molecules, so collections of atoms. But we'll introduce this later too. There's a few other ones, and we'll learn how to do them. But oh, I forgot the dots on this. One of them is to do Lewis dot structures or structures. You might just say in that. And so these are going to be representations of the molecule that show how they're bonded. And it's giving information about how electrons are shared or not shared. And so here is a representation of carbon dioxide. And the lines right here, the double line, this means it's a bond. And so actually each line is a bond. And a bond will be 2 electrons. So each one of those lines equals 2 electrons. And when I have 2 dots like this, those are just 2 electrons that are hanging out. And so this shows that the carbon is kind of central in the molecule, and it has 2 oxygens on either side of it. We can also do ball and stick drawings where we show so here's our oxygen, here's our carbon, and here's our oxygen here. And it shows the bond. So it shows that those 2 single lines, again, in between each carbon and oxygen, representing a bond. That way is kind of I don't know. It looks a lot like the way you can kind of put together these like handheld models. And then we have these space filling drawings. There are elements again that are trying to show how those volumes of electrons overlap with one another when they form these molecules. So I think it's a little bit more accurate. So of all of these, the one that we're going to use the most is going to be the chemical formula in this class, or the chemical name. And later we'll talk about the Lewis structure as well. Let's do this for something else. So this was a molecule that had covalent bonds. Let's do for something that's an ionic one. So let's do that sodium chloride we talked about before. So you can have its name, sodium chloride. And you can also have its chemical formula, NaCl. So note that there's nothing written in the subscript positions here. So that means there's 1 sodium and 1 chlorine atom for a unit. But in ionic compounds, they form like they're salts essentially. So like when you think about it, so sodium chloride is table salt. It's usually like big grains, right? So it's definitely more, each one of those grains is more than 1 sodium atom and 1 chlorine atom. because they're so tiny. And so they actually are representing here in the ionic compounds, it's really a ratio that if you looked at any amount, you would have the same amount of sodium as chlorine because it's 1 to 1. Now, in this case, the ionic compounds aren't actually sharing electrons. They're not overlapping at all. They're next to each other and they have charges associated with them. And so they're just being attracted as opposites are attracted. And so we don't have Lewis dot structures for them. If we tried to do that, what we would end up just doing is saying sodium is positive and chlorine is negative, and that's the attraction right there. And so similar, we're not really going to see ball and stick drawing so much. We will typically just see representations of like a solid or crystal, right? And we could call that a crystal structure. And so that might be a representation of the different ions in a larger kind of extended structure.